From the palatial Cadence Design Studios in the heart of Silicon Valley, it's So You Think You're an Expert, the electronics design industry game show that tests domain expertise. Today's segment, high-speed design, signal integrity, and Sigrity tools. And if you want to become an expert, sign up for a Cadence training class today. And now, the man who uses his flip phone when someone cuts him off in traffic, your host, Brian Fuller.
Hello and welcome back, everyone, to So You Think You're an Expert, the electronics industry game show that tests engineering expertise in some of today's most challenging system design areas. We're in round 2 of this month's contest, and our topic is high-speed design and signal integrity. I want to welcome back our expert contestant, Ken Willis, Product Engineering Director of High-Speed Analysis Products at Cadence Design Systems. Ken, welcome back.
Thanks, Brian. Good to be back. Things went so well last time I wore the same shirt for luck.
Excellent. Well, you killed it in round 1. You got all of those. You're batting 1,000. Now, I understand you're a member of Red Sox Nation, and you once played catch with Carl Yastrzemski outside of Fenway Park. Is that true? No,
it's actually not true. That's a myth. But what is true is I once shared French fries with Larry Bird on a park bench.
Wow. Did he dunk over you?
No, Larry Bird didn't dunk over anybody.
Wow. Okay. All right. So round 2 of 4. As I mentioned in the first segment, these questions are going to get tougher. All right.
Okay.
We're going to. We have the categories that you can pick, but for the first question, we're going to stick with the second one, impedance control.
Okay.
And again, if you get stuck, you can call a lifeline, right? We can go back to Dave Palumbo,
okay,
who was
He took care of us the first time.
He did take care of you.
Great job, Dave.
So let's go. Let's remain with impedance control and go with question 1, true or false. Series termination is typically the best technique for daisy chain routing topologies. True or false? You're on top of it.
I'm going to say false.
False. And why false?
Well, when you use series termination, you actually launch a lower amplitude wave down the line. So if you daisy chain many loads together, the loads that are in the middle of the line actually have to wait for the reflected wave to come all the way back from the far end before they reach full amplitude. That can cause timing problems.
Oh, yeah, and that's a big problem these days in high-speed design.
It is.
Wow.
Yep.
All right, bing, 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 you got the first question in the second round. All right, well, like I said, they're going to get tougher. So you ready for question 2?
Ready.
Here we go. What consumes less power, series termination or shunt termination? Series termination or shunt termination? What consumes less power?
Series termination is going to consume less power.
And that is because?
One less path from power to ground, bleeding off current.
2 for 2 in the second round, Ken. You are amazing. All right, question number 3. Now remember, if you need it, you can call a lifeline. You don't have to, but you can.
Right.
Okay, name the last U.S. president who hailed from Massachusetts. And hint, this is a hint, his name is not Michael Dukakis.
Okay. Let me think. Gotta go with JFK?
JFK. Excellent. Wow. 3 for 3. And before that, it was Calvin Coolidge.
Really?
Who'd have thought?
That's quite a gap.
All right. So, let's see. We've tackled a couple of categories. Let's pick one more. What do you think?
We'll take signal integrity effects for 300.
Signal integrity effects. It is. Question number 4 is line loss always bad? Deceptively simple question. What do you think, Ken?
You would think it would be, but actually no, it's not always bad.
Why is that?
Well, sometimes you get signals on those lines that you don't really want there. For example, crosstalk signals. So if you have crosstalk, it's actually advantageous sometimes to attenuate that crosstalk through a lossy line before it hits your receiver and actually distorts the signal.
You're learning a lot here. That's 4 for 4 from our expert here, Ken Willis. Okay, one more in the second round.
Okay.
And remember, if you need it, you have a lifeline. Okay, so last question. Near-end X-talk, otherwise known as next, propagates back toward the transmitter, and far-end X-talk, known as fexed, propagates toward the receiver.
Right.
And is that right? like you're struggling with that one.
In the textbooks it is, but there are cases where near-end crosstalk will actually propagate back towards the transmitter, but then reflect off that transmitter if there's not a perfect impedance match there, and actually turn around and then propagate to the far end of the line.
Wow. 5 for 5. Unbelievable. Unbelievable. Nice job.
Thank you.
All right, so that's it for the second round. Are you winded?
Yeah, I think I have to go lay down.
All right.
It's quite taxing.
All right, so why don't you lay down, take a little break, and next up will be segment number 3 as we continue our show, So You Think You're an Expert. Sean, any housekeeping?
Yes, we do, Brian. Viewers interested in becoming experts in high-speed design should check out Cadence comprehensive online training programs, and these include Sigrity Power DC and Optimize PI, and of course, Allegro Sigrity PI. And you can sign up just by going to Cadence.com/training or check out our link on the screen to follow that to our training programs. So for Brian Fuller and Ken Willis, my name is Sean O'Kane, and we'll see you next time on So You Think You're an Expert.